Hello everyone, welcome to my channel. In this video, we are going to solve some other questions of Unit 2 Kinematics. So before wasting in time, let's start with question number 11. Says, on a theme park ride, a cage is traveling upwards at a constant speed. As it passes a platform alongside, a passenger drops a coin A through the cage floor. At exactly the same time, a person standing on the platform drops coin B from the platform. So let's suppose there's a cage over here, a platform over here. One person is standing over here, and another is standing on here. If this person A drops coin A from here, and the person who's standing on the platform, which is stationary, is dropping a coin B. So here's a scenario. Question A says, which coin, A or B, reaches the ground first? So they say the which coin is hit the ground first. So refer this scenario and try to understand this problem and what is answer, A or B. Try to understand and think. The answer is coin B. So the reason behind is first say initial velocity of UB is zero. Why? Because platform is stationary, so UB is zero. Coin A is moving upward inside the cage because the cage is going upward with a constant speed. That means the coin A is also going has some speed, vertical upward direction speed. Let's say suppose UA. It is not zero. Okay. Coin A must first rise to a peak before falling, so it takes longer to hit the ground. That means suppose B over here, UB is equal to 0 and UAE not here 0. So it has gained some height, not like this. Okay, it has some extra height. So it covers the greater distance than the B. That's why the coin B is falling first and then UA. Now in question B says which has the greatest speed on impact on the ground. As I mentioned earlier, coin A has some greater height than a B. So coin A has get some more kinetic energy than coin B. So coin A has a more kinetic energy than B. That's why the speed of the coin A is high compared to the B. So the impact on the ground is mainly due to coin A than B. This is a question 11. Now we move forward to question 12. Says William Tell was faced with agnostic task of shooting an apple from his son Jimmy's head. Assume that William is placed 25 meters from Jimmy. His crossbow fires a bolt with initial speed 45 meters per second. The crossbow and the apple are on the same horizontal line. At what angle to the horizontal should William aim so that the bolt hits the apple? Now, consider the scenario like this. They say a crossbow and the apple is on the same horizontal line and it fires some initial speed 45 meters. So the trajectory of the bolt is considered like this. Okay. So the initial velocity, let's suppose I say u here, 45 meters per second. And the distance between William and the Jamie is 25 meters. Okay. Now we have to need to find the what angle should be. So this angle theta. So uh, if I consider this scenario, I recall formula range. So the range formula says u square sine 2 theta upon g. So we have a u here, 45 meters per second. We need to find theta over here. We know g and r. R here is 25 meter. R says the horizontal distance. Okay. R denotes horizontal distance. So put the values and you will get the answer in degree, 3.48 degree above the horizontal. So if I draw trajectory here, this angle theta, and this is above the horizontal axis. Let's suppose it is x, this is y. Okay, this is the question number 12. Question number 13. The position of sports car on the straight track is monitored by taking a series of photographs at fixed time intervals. The following record of position X was obtained at started time t. So uh, we have here time at what time the position of the car. Okay, at zero point 0.5 second we have a zero point 0.4 meter. So this is about the table of time and the position of the car. Now we have to draw on the graph paper the plotting of x versus t and the velocity versus time. So the position versus time graph it shows like this. Put the values over here first. First you have to uh, draw a scale. What is in the x and what is in the time? Okay. So this is 1, 2, 3, 4, 5, and in the position x-axis you have 10, 20, 30, 40, 50. So you have to plot like 0, 0, here 0, 0, and zero point 0.5, zero point 0.4. And if you do all the points and you just have to connect all these points. Now, for the velocity versus time, we didn't give, we have not velocity over here. So we know the formula of velocity is dx upon dt. So by doing this, you will get the velocity values and you already have a time values. So put the values of velocity here and the time and just connect the dots by the line. So this is about position versus time and the velocity versus time graph. 14. In a driving manual, it is suggested that when driving at 30 meter per second, like 45 kilometer per hour, a driver should always keep a minimum of two car lengths between the driver's car in one of front. So, suggestion a scientific justification for the safety tip, making reasonable assumption about magnitudes of any quantities you need. So, in the driving manual, they say the we need the distance. We have to keep a distance of two car lengths. Why we need two? So, give answer as a physics perspective. Okay, perspective. So, in the solution, think about the driver's typical reaction time. So, what is the typical reaction time? Means when a driver drive a car on the road, when he or she sees some obstacle on the road, and he took time to overcome this, and the time required to overcome the thinking about the obstacle and react to it. It's called the reaction time. So typically it is about zero point 0.7 second. Now they give a initial speed 30 meter per second. So here I write u 30 meter per second. Now the car travels during the time interval of the reaction time. So it is about 9.1 meter. So the 9.1 meter shows the distance traveled by the car during the reaction time when the driver is actually reacting to this obstacle. So now the think of car length. What is car length? Typically, it's about 4 to 5 meters, and we need to consider here two cars. So it is multiplied by two, means 8 to 9 meters. Here you can see it is a reaction time takes zero point 0.7 second, and this time interval car can uh, take distance on 9.1 meter and the same distance over here, the length of the two cars. That's why they say uh, we have to keep a minimum two car lengths. If we are not keeping that distance, so it might be collide cars. Okay. Now the second question says, how would you expect the length of the exclusion zone to depend on the speed for the higher than the 30 meter per second? So in the A, we have solved of 30 meter per second only. If you drive a car greater than the 30 meter per second or 45 kilometer per hour, so what should be the length between the two cars? Okay, for that, the reaction distance, the travel, the car travels during the we have to react time, and the braking distance. So you just have to do brake, but car cannot stop at the right moment. It takes some distance before the stop. Okay, so it is given by like this: v square upon 2a is a deceleration over here. So you have to just add these two distance. Okay, so if the front car stops suddenly, the driver behind needs some distance for both reaction distance and braking distance. Therefore, the length of the exclusion zone, you say, the increase quadrilaterally rather than the linearly. So this is the kind of practical question I would say. In this question, we use our kinematics concept over here and try to understand why they give a driving manual. In driving manual, they say keep a minimum distance of two cars. Okay. Now we move forward in question number 15. 15 says a student standing on the platform at a railway station notices that the first two carriages of the arriving train pass her in 2 seconds. The next two carriages took a time of 2.4 seconds. Now, the train D is decelerating uniformly. That means we can use here equation of motion because accelerating or decelerating uniformly, that's why we can use equation of motion. So each carriage is 20-meter long. Okay, they given us the length of the carriage. Here you can see the difference between the passes time. Here is a 2 second and the next two take 2.4 second. But the carriage has same length. So in this difference, we can easily say that the train is decelerating. If they are not given to this us, we can also observing this quantity, this value, and this, we can easily say the train is decelerating because for the next two carriages, it takes more time to pass through her, okay, rather than before. So we need to find when the train stops. The student is opposite the last carriage. How many carriages are there in the train? Okay, so person or a C is standing over here. The train is going to opposite her, and this is passing through like this. Okay, okay. So we need to find the how many carriages are in the train. So every each carriage is 20-meter long. We have a first for to pass 2 seconds, and the next two carriages passes in 2.4 seconds. So try to understand this scenario and try to solve and apply the equation of motion. Now, here I write what is the given data over here. The length of two carriages is 40 meter. First two carriage 2 seconds take time. Second 2.4, and the total length of four carriages is 80 meter, and the total time is 4.4 seconds. Now apply the equation motion over here for the first two carriages. So we use this equation. This equation, it says a displacement of 40 meter. Okay, 40 meter u. We don't know what is the initial speed of the train. We know that t get 2 seconds to pass the 40 meter means two carriages. So right here 2 u plus half a. We don't know what is a over here, and we know t, and we got equation number one. Now just do same thing with the next two compartments. Here total uh, distance covered by the train means four compartments. 4 into 20 means 80. Okay. And the total taken time to pass through her 4.4 seconds. So put the values over here and you will get this second equation. So we have a two unknowns and two equations. We can easily do some apply a mathematical operation, and you can say it is the elimination method we can use. Okay, we got the answer of u this, and a is minus of this quantity. Here another indication, the train is decelerating. Okay, now the total distance to come to rest. So after the train stops, the final velocity of the train is zero. Here I write. Now we use this equation over here. We know, 2 A is also we got, and then we need to find what is S, what is the total distance, okay, which is 152.8 meter. Okay, so this is the length of the train, but we need how many compartments or carriages are passing through. So this is the length of the train, or we know that each carriage has a length of 20 meter. So we have to just divide by it. We got the answer of 7.64. Since the student is opposite to the last carriage, the train has total 8 carriages. Why we need not 8 over here? Because the eighth compartment is the person standing here, and then this is not actually whole passing, it is middle of it. Okay. I hope you understand the question number 15. Okay. Question number 16 says a ball is to be kicked so that at the highest point of its path, it just clear a horizontal crossbar on a pair of goalposts. The ground is a level and the crossbar is 2.5 meter high. So in this case, you have some height over here. Okay. The ball is kicked from the ground level with an initial velocity of 8 meter per second. Now, in A says calculate the angle of the projection of the ball, the distance of the point where the ball was kicked from the goal line. So solution A of review is 8 is 2.5 meter at the highest point. U is initial velocity, they given us 8 meter per second. And here we have to consider G as well, 9.81 meter per second as well. So at the peak of the path, the vertical velocity Vy is should be zero. Okay. And we use this equation. Here is the initial speed. Let's suppose this is a kind of projectile motion over here. This is theta and uy, ux. So uy over here is u sine x. Okay. If you project projection over here is equal to u x sine theta. Okay. Whatever the angle is. So we need to find angle over here. We have Vy should be 0, 2, we know G, we know the edge over here. This is about, we got 6.61.1 degree. Now, question number B says also calculate the horizontal velocity Vx of the ball as it passes over the crossbar. Okay, so we need to find what is peak time required to reaches the peak. Okay, so it means u sine theta upon g, and we know g, u, and theta. We got the answer 0.714 second. It means the time required to gain some this distance over here, the peak position. Now the distance to the goal to line is u cos theta into t peak, and we got the answer of 2.76 means this. Okay, now for how long is the ball in the air before it reaches the ground on the far side of the crossbar? It means how will it take a time from this position to the this position. Okay, for that, you know the horizontal velocity is u cos theta 3.87 meter per second. The total time in the air is twice of the peak. T peak means this point, the position from here to here, and it require the same time to going from this position to the this position. So we have to just multiply by with peak time if you need this whole journey's time. Okay, so twice into t peak, and you got the answer 1.43 seconds. So this is all about question number 16. Now, question number 17 says an athlete competing in the long jump leaves the ground at the angle of 28 degree and makes a jump of 7.4 meter. It is also a problem regarding the projectile motion, which is same scenario like this. Okay. In this question, they give a range or this is a horizontal distance. Now, we need to calculate the speed at which the athlete took off. So we need to find the initial speed. Okay. I hope you easily understand this kind of concept because we have already so many questions regarding this. So we have a range over here. U we need to find. We gave theta, 88 degree, and G we all know. So the answer is 9.36 meter per second. Now, the question B says if the athlete had been able to increase the speed by 5%, what percentage difference would be have made length of the jump? So what is the difference over here in R if we increase the U of 5%? Okay. So here the for in order to answer this, we need to take R proportional to U square because we didn't change G. We didn't change angle of projection. I would say theta. So we are proportional to U square, make it set as constant values. So we have a change U dash by 0.5% means 5% of U plus U. Okay, I write here like this. And final velocity is 1.05 times U. Okay, so put the values over here and you will get 1.05 square U square. We already know what is the U square. Okay, here I write only R. And the square of the is quantity is like this and this into R. Now we need to find a percentage difference. So R prime minus R means 0.1025, and the percentage change we have to just multiply by with 100, and the percentage change in R is 10.25%. So that means the increase in the horizontal distance, or I would say range, is 10.25%. Okay. I hope you clear this concept. Question number 17. It says a car travels due north at a constant speed, 30 meters per second for 2 minutes. The car then travels due east at constant speed, 20 meters per second for 4 minutes. What is the total distance be traveled by the car? Okay. So we need a total distance. So you don't bother about the where it go, north, south, east, west. No. You have to just get distance, the first case, then you will get the distance of the second case. You have to just add it rather than bothering about the direction. So in the north, 30 into 20, 2 into 60, because we need in seconds. Okay, so multiply by 16, and we got meters 3600. And the second in each direction 4800 meter. You have to just add, but in the displacement, you have to consider direction also. But in this case, they give a total distance and you will get 8400 meter. It's a simple question. Okay. Now, question number 19 says a ball is thrown vertically upward with the initial speed 20 meter per second from the platform 50 meters above the ground. The ball travels to a maximum height and then returns to ground level. How long does the ball take to travel from the platform to its maximum height and then to the ground? Okay, this is also a simple question, I would say. U is equal to 20 meter per second. S is minus 15 because we take upward direction as a positive, and G is always there. So S is UT plus half AT square means here I write minus because G is negative over here. So U is minus 15, U is 20t. We need to find T over here. By solving the quadratic equation, you know the A, B, C, and this formula, and you will get the answer is 4.72 second. Okay, this is the answer. Okay, a ball is thrown at angle to the horizontal of 30 degree with initial speed of 45 meter per second. What time does ball take to return to the same horizontal level as its reference point? So this is the also same problem. 45 meter theta degree 30 degree, and is twice into t peak. Okay, okay. I would say. So what is the time required to go along this way, this position to this position? So you got the answer 4.59 seconds. Okay. This is all about today's video. Now we have a remaining some questions. So we will discuss those in our next video. So keep practicing, keep learning, and keep thank you for watching my video and subscribe for more physics lectures.